Hello, everyone. Sorry for short delay. We are continue. Please welcome our next speaker, Jean-François.
Good morning. So thanks for choosing my talk. So today we will talk about MySQL replication. My name is Jean-François Gagné. I currently work at MessageBird, the t-shirt I'm wearing right now. But before that, so I joined MessageBird in July, so only for a few months. I don't have a lot of things to talk about what we're doing at MessageBird from a technical point of view. My previous employer was Booking.com, so I will refer to a few things about Booking.com in those slides. But first, I'll quickly say a few words about my current employer, MessageBird. So MessageBird is a cloud provider, telco cloud provider. I would call that new telco 2.0, to use a buzzword. So we do text messages on the internet, SMS, like what use is an SMS today? Well, think about 2FA. Think about telling you that the pizza you order is just arriving. So those are things that we do at MessageBird. We also do voice, automatic voice system and things like that. MessageBird is a small startup in Amsterdam, but we're founded in Amsterdam a few years ago. But we're global. We have offices all around the world. And as all startup, we are expanding. So we're not exactly a startup anymore. Like we have almost 200 employees. So we're a scale-up. We're in the growth phase. And if you want to know more about us, come to me a little later. I have a stack of business card here. Our stack is PHP, Go, a little Java, Python. So we do cool stuff. But no, you're not here to hear about MessageBird. You're here to hear about MySQL replication. So the summary of the talk and my goal is to give you an overview of the replication landscape to allow you to start exploring replication, solving the problems you have right now. So I will introduce replication, talk about what it is, why you would use that, and how you can use this. I will talk about some replication generalities like tooling, talk about lag, like place some basic knowledge before being able to dive into the use cases of replication. I'll give a little war story and I'll do some closing remarks on scalability and sharding. Along the way, because I cannot dive very deep in all the subjects, I will mention advanced subjects and I will give you link to go deeper in those subjects after the talk. And there's no need to take pictures of the slide. I will put them online. So before talking about replication, we need to set the landscape of our story. Where do we start? And we're starting at, you have an application, you have a database, which is the master, where all reads and writes are done. So you don't have replication yet. Or maybe you have one slave to take backups, but probably you don't have slaves at all. Like you're not reading from slaves yet. And certainly, but maybe not, you have binary logs enabled on the master. You're using a recent version of MySQL. We're not talking about MySQL 3 or 5.1. We are either MySQL 5.5, hopefully not, but there's still a lot of 5.5 around. 5.6, 5.7, and maybe 8.0. 8.0 was released this year. Or some other version of a fork like MariaDB. And you're not using MyISAM, obviously, like you're transactional. You use InnoDB or another transactional storage engine. So what is replication and how does it work? So replication, there's one master where all the writes are going. So all commits are putting data in the database in InnoDB. And at the same time, the master is appending data to a journal. It's a replication journal, the binary logs. And this is where all the data of replication is stored. A slave is downloading those binary logs. This is the job of the IO thread, and is storing them locally in the relay logs. And then another thread, the SQL thread, is reading those relay logs and is applying those changes in InnoDB in a local database. And eventually, this slave is also producing binary logs. So this slave can be a master for another slave. So this is intermediate master, and replication can go further down this way. And all this process is asynchronous. So there might be a delay of a few milliseconds, a few seconds, a few minutes between when a transaction is put in the binary logs and this reaches the database where it's readable by application reading from slave. So all this might take time, and this is replication lag. This is the delay that some of you might already know, like this happens in replication because it's asynchronous. We'll talk about lag later. So why would you want to deploy MySQL replication? So I see many use cases. I will quickly mention them here and explore some of them later. The first use case is to have better backups. I will not talk about backups. My talk was too long when I rehearsed it, so I'm skipping the backup part, but the content is still in the slides, so you can refer to that later. The three use cases we will describe today are reading from slave and failing over the master. So reading from slave can be done for two reasons, because you want a better reliability on your reads. If a node fails, you want to be able to read somewhere else, and MySQL replication allows that. Another reason you might want to read from slave is for scalability. If you have a lot of reads and a single database cannot serve all those reads, well, you want to do many slaves and you read from many nodes. And another reason why you might want replication is to be able to fail over the master to a slave, so to restore the rights in case of a failure of the master. So we'll also cover that. And there are other reasons you might want to deploy replication. I'm not going to talk about those. Those are advanced subjects. So aggregation, replicating to Hadoop, and eventually testing new versions of MySQL, those are other reasons that you might want to have replication. So we're starting without slaves, so I have to tell you how to set up MySQL replication. So the first thing is to enable binary logs. So it is surprising, but it's not enabled by default in older versions of MySQL. In MySQL 8, binary logging is enabled by default, but not in 5.7, 5.6, or 5.5, so you have to do a little work to enable that. And sadly, you need to restart MySQL to do that. So make sure if you deploy MySQL to enable binary logs to avoid having to restart MySQL later. Then you have to specify a unique server ID. So the server ID is an identifier of a node in replication, and each node should have a different server ID. You can change the server ID online, and a good hint, instead of numbering 1, 2, 3, 4, like this is what you see in the documentation, just use the last 3 numbers of an IP address. So you don't have to think about this. Usually the last 3 numbers of an IP address are unique, and this is a good server ID. And it avoids you to think, did I already use 3, 4, 10 in my replication setup? Then you also need to create a replication user, because a slave will need to connect to the master with a MySQL user to download the binary logs. So how to do that is explained in the manual. 2 other things that a master has is with MySQL 5.6 or more recent, a master also have a UUID for GTIDs, so it's a new way. So it's kind of a server ID, but it's closer to the GTID features. This is somehow an advanced subject, but like you should be familiar with like a UUID exists to identify a master. And there are many binary logs format. So Oracle is going row-based replication by default from MySQL 5.7, but if you're still using MySQL 5.6, by default it's another way of logging transactions. which is statement-based replication, you probably want to change that to row, because in the future, Oracle is developing all new features based on row-based replication, and changing that is a pain. Going from one to the other is complicated, so start right away with row-based replication if you use MySQL 5.6. And then, when all those things are done, the only thing you have to do to create a slave, because all those things were done on the master, is to restore the backup and set up replication on that slave. So when you do a backup, you usually know at which position this is in the binary log of the master. And then by restoring a backup and connecting it to the slave, to restoring a backup to create your slave and connecting to the master, now you have replication. A quick word on GTIDs. GTID is a new feature of MySQL 5.6. It is pretty useful for failing over and agility in general. So you probably want to enable GTIDs if you're starting from scratch, because it's pretty hard to enable GTIDs in an existing replication setup. So enable GTID from the start, and if you're using MariaDB, well, you're lucky, GTIDs come for free. GTID is not a feature that I really like, but I need it for some other use cases. Failing over is something that needs GTID. But there's something better, in my opinion, that you could use. It's binlog server, but it's an advanced subject. If you want to dive into that, you can read this. It's a little small, sorry. So the slides will be online. I will skip this part. So those are advices, things to avoid, or things to be careful about. I'll let you read that in the slides later. So now I've explained to you how to set up replication. We will still talk about why later, but you might also want to have some tooling to see your application setup. And there's two tools here. There's Orchestrator, which allows you to visualize a replication setup. Here we have a screenshot of a replication setup at booking.com. We have the master here, which is MySQL 5.6 using row-based replication, 3 intermediate master, and here it's collapsed slaves. There's 44 slaves from that replication, from that intermediate master here, 43 and 11. So this is a pretty big replication setup. Booking.com is known to have very, very wide replication setup. But this tool allows you to visualize your setup. It also allows you to fail over. We'll come back to that later. But deploying this tool takes some time. So there's another tool called ptslavefind, which just prints on the right replication. It might be easier to deploy from the start. And one last thing before we talk about the use cases, we have to talk about lag. So I quickly explain what replication lag is the delay between committing something on the master and this being applied on the slave. I consider that the biggest enemy in a replication setup, and there's 3 types of lag. The first one is temporary lag, maybe because you're restarting a node and because it was stopped for some time, it needs to catch up. Or because you restarted a node, the cache of MySQL is not warm, so transaction executes slowly there. But this is something that flicks itself with time. Something else is occasional lag, which is self-inflicted. It is usually caused by a burst of write on the master. And because those transactions cannot execute quickly enough on slave, it will take some time on the slaves to execute all those. Because sadly, a master has more write capacity than a slave in general. So we have to be careful not to overload the master, and I'll give some hints about how to do that. And there's perpetual lag of death. It is not a burst of write on the master, it's all the time you write too much on the master is able to sustain this write throughput because InnoDB is getting very good at executing transactions in parallel. But because the slave is single-threaded or limitedly multi-threaded, the slave is not able to execute all those transactions. And at this point, you have a capacity problem. You need to solve that capacity problem. There are two tools to monitor lag. So there's a command which is called show slave status that you can run on a slave. It will give you second behind master, which is one way of seeing how much lag you have. There's another tool that you can Google from the Percona toolkit, which is PT heartbeat, which injects transaction on the master with a timestamp. It's a heartbeat, and then you look at the last heartbeat that a slave has, and if it's lagging by 5 seconds, you'll have a delta of 5 seconds between that heartbeat and now. And there's a new feature in MySQL 8 to monitor lag. I haven't looked into details there yet. I'm not on MySQL 8 at MessageBird. So there's something there. You can also look at this. Here's an example of lag at Booking.com with Orchestrator. So we have an intermediate master here that has 46 seconds of lag. We have a slave of that intermediate master, which is up to date with its master. It also has 36 seconds of lags, and those two slaves here lag by a little more, 56 and 188 seconds of lag. So Orchestrator also allows you to see lag. And here is a much bigger lag. We have an intermediate master lagging by 5,600 seconds. There was a very inefficient transaction flowing through replication here. This transaction was completed on that intermediate master, but now is executing here. It will take, again, close to 100 minutes to run here. So this setup was lagging by 4 hours for some time because there was a bad transaction flowing through replication. So what is a bad transaction, and how can we avoid that? So 3 ways to avoid lag, and like the first two ones are quite interesting for you. I think most of you are developers. So it's to avoid long or big transactions, and it's also to manage your batches. When you do a batch that will write a lot on the database, by doing this in a smart way, you'll be nice to the database and you will not generate lag. The third one is both DBAs and developers is to do things to increase throughput. We'll see those 3 in details in the next 3 slides. And if all those fail, well, you have a capacity problem. You need to shard. So long transactions. So we do not like in a replication setup a transaction that is taking seconds to execute. Because if a transaction is taking seconds to execute on the master, it will take seconds to execute on a slave. So one of the things that we do not like is something that is unpredictable. Like deleting a single row that is a foreign key and that will delete hundreds, thousands, millions of other rows because of undelete cascade. It's not something we like because this is generating an unpredictable, it's an unpredictable delete. So at Booking.com, foreign keys were completely out of boundaries. Like we do not use foreign keys at Booking.com. Something else which is similar to that is updating or deleting many rows. Like where date smaller than a year ago and delete everything that is a year ago, you don't know how many rows that will delete. It might take 2 seconds or it might take an hour to delete all those rows. So if you need to update or delete many rows, don't use a where clause that is unpredictable. Update or delete by primary key many times, one after the other, in some small transaction. So the first thing to do is to split those big transactions in smaller transactions, and then to make sure that those small transactions do not overload replication. Alter table is a big transaction. It will take time to alter a table. Oracle is making more and more online alter, but when this alter, so the table is altered online on the master. Transaction can happen on that table while it's being altered. But when it reaches a slave, that alter table blocks everything else. So if the alter table, adding an index, as an example, took an hour on the master, it will generate an hour of replication lag on the slave. So there are tools to do that online. And even if Oracle right now and other database vendors are getting good at making things happen online on the master, it's not a solution in a replication setup. Things need to be instant to be nice in a replication setup. And you need row-based with row-based replication, if you don't have a primary key on your table, things will go very badly. Like, always have a primary key on your tables. And if you want to know more details, there's a link here. I'll skip that. And I'll go now to batches. So we already know that we need to split transaction. So a long transaction needs to be split. If you want to delete all the rows that are older than a year, select them and then delete them by primary key in different transactions. But if you do that too quickly, you overload replication. So manage chunk size, small chunk size, and don't send that all at the same time on the master. And so you have to do a sleep between each of those transactions, a few milliseconds, a few seconds, but the question is how much? And so you need to have a notion of how much load there's on replication. And so at Booking.com, there were some advanced techniques that which are called DB waypoint. It's basically injecting transactions in the master while we're doing stuff, and then looking when those tags gets on the slave. And when a tag gets on the slave, it means that replication has catch up and you can continue. So it's a way to throttle batches. And it's quite interesting, and if you have this kind of problem, this could be a solution for you. And the last thing, increasing write capacity. I just look at the time. Increasing write capacity by making write more efficient using SSDs or parallel replication. All those things are solution if you have a throughput problem. And be very careful with those parameters. They do improve replication speed by relaxing durability, but they have consequences, and that can cause you problem long term. So know what you do if you touch those two parameters. Now is the time to talk about the use cases. Now that we've set up the whole subject of replication. Backups, I'm skipping. Reading from slaves. So I already talked about the 3 reasons why you want to read from slaves. But reading from slave means dealing with lag. And so if you read from a slave that is lagging, you will have data from a few seconds, a few minutes, or even a few hours ago. So this is not necessarily a problem if you do not present inconsistencies to the user. Reading data from a long time ago is not always a problem. What you need to do is having a consistent read. And especially a problem is if you read from a lagging slave, and then just after that you read from a slave that is up to date, and then later you read from another lagging slave, you present data that changes to the user. So you want to present data that is always going forward to the users. I'll talk about how to do that. And there's more complexity about, like, when you have 1 or 2 slaves, it's not that complex. You know which slaves you have. But when you have a lot of slaves, you need service discovery. I will not cover in details how to do that, but a few good ways of doing it is DNS, proxies, load balancers, pooling. So there are other references on that. When you start, proxy SQL with a load balancer is good enough. And once you reach a certain scale, every centralized way of knowing where your slaves are will be a bottleneck. So depending on the scale you need to think about centralized versus decentralized. So if you want to improve resiliency, like if a node failed, you want to be able to read, there's a bad strategy that you should avoid. Is if you always read from the master, and when the master fails, you read from a slave, that's a bad idea, because you hide the problem of lag most of the time. So don't do that. Read from slaves to actually face problems with lag, and if the slave fails, you'd read from another slave or from the master. So avoid naive solution like if my master fail, I will read from slaves. That's a bad idea because when the master will slave, you'll have lagging data. Other bad ideas that this time is not about resiliency but about lag is if you have a slave that is lagging, reading from the master to have actual data is a bad idea. It would solve a lag problem. But if you have many slaves and you're reading from slaves for scaling, like you have to think, like if I read from the master and I actually overload my master and I kill my master, that's a bad idea. So it's better to fail a read than to fall back to the master. There's some reason you might want to read from the master, but you really have to avoid having a cascading effect of some slave are lagging, I read back from my master, and then I kill my master. But if you cannot read from the master, maybe you could read from another slave, and this is also a bad idea. Because if you have some slave that start lagging, and you focus all the reads on the other slaves that are healthy, you're actually increasing the load of the healthy part of your infrastructure, and you might kill it. So again, failing a read or making sure that your reads are consistent is better than having bad techniques that will cause bigger problem. We have to train a lot of people when they join Booking to avoid doing those things. So I'm already like giving you that hint. Avoid those bad ideas. And the way to cope with lag is either to use algorithm or methods that will do consistent read, like proxy SQL, or DB waypoint. So those are advanced techniques, but in the abstract, I mentioned read views. So the idea of a read view, the way this is done at Booking.com, is to use a waypoint, and if somebody just writes something to the master and we want to read that data, reading from the master, not a good idea. So what we do is at the same time as we write data on the master, we inject a tag. And when we want to successfully read from a slave, we make sure that this tag is on the slave, so has arrived to the slave through replication. So this is called a waypoint in the Booking.com infrastructure, and this is a way to enforce consistent reading of data. GTID is a way to do a waypoint, and there's something called wait for GTID that allows to do consistent reads the same way. So this is about reading from slave. Now let's talk about failing over the master. I'm just checking time. Yeah, I have 10 more minutes. So if you want to fail over the master, because the master is a single point of failure, there are like a few things that you should be aware of, like dealing with lag as an example. So it's not as easy as it sounds. And there are many corner cases that you need to be aware of when you fail over to a slave. An example of a complete failover infrastructure was published by GitHub. We'll come back to GitHub a little later. So once you know that if the master failed, you want to fail over to a slave, so this is your plan, you need to know when you're going to do it. You need to tell your application where the new master is. This is service discovery. The first part about the when is failure detection. And you need to make sure to protect your application and your data against inconsistencies. And if it fails, you need to be able to fix your data. So we're going to talk about those steps. So failure detection is to decide when you will fail over. And this is a hard problem. People are writing PhDs about like failing over. And it's known to be very hard to do in a reliable way. And if you want to combine reliable and quick, it becomes impossible because your confidence about failure grows over time. And it's impossible to reach 100% certainty about failure. So quick failure detection is unreliable. And relatively reliable failure detection is long. So you will be unavailable for a long time. So there's one thing that absolutely you need to accept is that failure detection will generate false positive. And like you need to deal with that. Repointing, so reorganizing the hierarchy if you have two slaves of a master is relatively easy if you have GTIDs. So Orchestrator and other tools are doing that. And this is relatively easy. This is not a hard part of failover. Failure detection is the first challenge. Service discovery is the second challenge, because if it's centralized, it's a single point of failure. If it's decentralized, like part of the infrastructure might think about the old master and still point to the old master, and with unreliable failure detection, this is a problem, and other part of the infrastructure is thinking about the new master. So this is a split brain. So it's when you have two nodes that are potentially written at the same time. And you need to avoid split brain. So this is the third part, is to protecting against split brain, which there's not a lot of good solution for that. Facebook is using semisync to do that. Other people are using proxies. But it's always a trade-off between the certainty of having the master in one and one only place and being quick about failover. So if you have a split brain, you need to fix your data. And fixing your data is really hard with auto-increment. So I would advise you to avoid auto-increment and use UUIDs instead. So just to explain all I just said, I'll talk about something that happened at Booking.com. It's a talk I did at FOSDEM a year ago. And if you want to know about other bad things that can happen with failover, GitHub had an incident about a month ago that involved MySQL database and failover. They wrote a complete postmortem about this, and it's very interesting to read. So what happened at Booking.com is that we had a master, A, and a slave in the same data center, B, with another data center, X and Y, where like we had an intermediate master and another slave. Writes are happening on A, reads on B and X, and so far everything goes well. So this is a pretty simple deployment. What happened is there was a double failure. I cannot explain why, but just trust me, it happened. Sometimes double failure happen. And so writes were not happening, and reads on one data center didn't happen again, didn't happen anymore. So this is a very simple failover. We just fail over to X here. And from that moment, everything is working well. So we went back to sleep, like the ops team, everything was good. But then a little later, something happened on the day after. We woke up with writes happening on B, reads happening here. Do you see the problem here? Yeah, the problem is that write happen on X, and those write reaches Y and are able to be accessible to the reads. But then the writes that happened there for a few hours, this lasts for 8 hours, were not on B, and now data was written on B. So that was a pretty bad scenario, and it happened. So at this point, we were stuck and trying to reconcile the data. Auto increments were in the way. So from that moment, I really stopped creating tables with auto increment, because if we think about auto increment being allocated on X here, let's say we were at 100, 101, 102, and so on, like those were also allocated on B, on other data. So it was pretty hard to fix this. One advice is avoid auto increment. UUIDs are much better, and there's a way to have UUIDs in order. By default, UUIDs are random. Having UUID in order to be nice to the database is better. So failing over is not easy. You should try it, you should go there, but if you go there thinking that it's easy, bad things will happen. And one such bad thing, like maybe you say, like, is there a solution to that? Have you ever heard of an easy way of doing failover? That's obviously not easy, but have you heard of this? Cyclic replication, ring replication? Because some people are doing this for easy failing over. But there's no such thing as a free lunch. It's not easy. Having a cycle here and failing over the writes to S here, we have the primary and the standby. Failing over to S if something happened is a bad idea. And I have a sentence here, sorry, it's hard to read, right? Friends do not let friends do ring or circular replication. And people think it's easy here and it looks attractive because like it's already, like the application can easily fail over to S. But it's a bad idea. Failover is not easy. All those things will happen. If P fails and we write to S, there's still some data that is not replicated to S. And when it will come back, this data will arrive out of order to S, or failure detection will happen in a bad way. Half of the application will write to P, half of the application will write to S. Really don't go there. The right way to do that is not to have ring replication, is to have single replication in one flow. And to do failure detection, failover, and service discovery. So if P fails, the first thing to do is to detect the failure, to failover and to repoint the writes, and to fence the master. And fencing the master here means stopping replication on S. So if some things happen on P by mistake, it doesn't break the data on S. And hopefully there's no writes going there because you've made sure that all the applications are consistently writing to S. So don't do circular replication. It's a bad idea. And if you think you can still do that, well, embrace split brain. Like if you think that there's an architect at your company that is trying to say, hey, we're going to do ring replication, and because he's a higher paid person than you, like, okay, we'll go there, and tell him, well, then we should write to both, right, all the time. And if it doesn't scare him enough, like, talk to him about this. Like, there really is no good things that can happen from that. The only true master is Galera or group replication. So I'm not an expert in those technology, but they're interesting. I'll just mention it here. The first thing that Galera and Group Replication does is multi-master in a safe way, but they do not do better failure detection. Failure detection is hard. What they guarantee is if you write to many nodes, your data will be consistent. And it's an interesting thing to do because if failure detection, you relax failure detection and you write to many nodes, then this solution will keep your data consistent. But to be able to keep your data consistent, once in a while it will fail a transaction in case of a conflict. And failing transaction to me doesn't really look like high availability. So it's more a consistency solution. And it's interesting, but it's an advanced subject, and going there is complicated. So you could go there, but like, know that this is an advanced subject and it's a complicated setup. I will skip semi-synchronous replication. And so to conclude, like, replication is an interesting subject, but it's quite wide. I hope I gave you the right tools to apprehend a few of the things that you might want to do, either do better read scalability, do better read reliability, and start to think about how to fail over. In my abstract, I said about why foreign keys are bad and why you shouldn't use auto-increment. I covered those two. But there's something else in my abstract that I talk about unique key and archiving. So I have one slide on that. I was planning to talk about sharding, but obviously I don't have time to talk in details about sharding. But there's two types of sharding, splitting and which is vertical sharding, and horizontal sharding, which Facebook is doing a lot, put your data on many nodes. So archiving is a kind of split. Part of my data is in my hot database, part of my data is in a cold database. It is interesting to tackle a growth problem for a limited amount of time, but if your data grows a lot, those two things will be too small. So it's a short-term win. Splitting is a short-term win. And when you split, foreign keys and unique key do not work well. So be very careful about using foreign keys and unique key, because when you will want to go to sharding, you won't be able to enforce consistency of your data with foreign keys and unique key. So those tools are interesting when you have a small data set. If your data set is growing, I'm not sure you should use those because they will be in your way at some point. So I'm done. I have in my slide five pages of links, mostly links that I gave in the talk. So all those things are more reading about replication. The last one, there's a few interesting things about optimization that you could do, some reading about sharding. A quick reminder about my employer that is allowing me to come and speak to you. If you have questions, feel free to ask me later. There's a stack of business card here. And how much time do we have for question? That's so. For one question?
Yeah.
Okay.
Thank you. Just one question. So you just said for such a scale, you basically just totally, not totally, but really discourage people from using foreign keys. Also known as like heavily denormalizing data, also like going into like NoSQL way. For what reason, or maybe you tried to leverage some other existing modern things which are designed to store data scalably and in non-SQL way, like CockroachDB comes to mind, or Cassandra.
Yeah.
Why are you stuck with MySQL? Thanks.
So NoSQL and you mentioned denormalization and NoSQL. NoSQL is a completely different subject. I need a lot of time to answer that question, so I'll dodge it. In short, there are advantages and drawbacks to work with MySQL, and there are advantages and drawbacks to work with NoSQL. And the biggest drawback of NoSQL is fully understanding the consistency model of this, which is very complex. NoSQL relaxes a few things, but you have to fully understand what they're relaxing and to work around those things. The only thing that MySQL replication relaxes is lag and eventual consistency, which people understands pretty well. And there's a lot of complex things that happen on the other side. So NoSQL, be careful and fully understand those things. I see a lot of people moving to NoSQL, failing there and coming back to MySQL. So you can avoid this back and forth, and like some people lost years there. The other thing is you talked about denormalization, and which I also call materialization. It's a way to optimize reads, but it's a whole talk. So I can talk about that more, but probably outside after the talk.
Thank you. For all further questions, you can talk with Jean-François after the talk. Thank you one more.
Thank you.